Hello everyone, this is Lakshmi. Welcome to my channel Lakshmi Lucky. So today we are discussing about functions ma. Okay. So introduction we'll see. First we need to discuss order of pay. Okay. So here suppose you should take A and B be two non-empty sets. Okay. Non-empty sets means ma, it should be contains at least one element in each set. Okay. So A is non-empty as well as B is non-empty. So here these two are two sets we are taking. Suppose A contains at least one element, we are saying no, A belongs to A and B belongs to B you should take. In this structure A comma B is there. This pair is nothing but we can say order pair. Okay. So suppose you should take A is nothing but singleton element A and B is equal to singleton element B you should take ma. So order pair is nothing but we can say, we can write like this A comma B. So suppose some elements A is equal to set of those elements 1, 2, 3 and B is 4, 5, 6 we are taking. So in this A union B, union is nothing but combining all the elements. Club the elements ma 1, 2, 3 and 4, 5, 6 కలిపి రాసేసేయండి. Okay, that is A union B. But order pair is nothing but 1 comma 2 and 1 comma 5, 1 comma 6, 2 comma 5, 2 comma 4, 2 comma 6 like etc. we can write. Okay, in this form we have to write. This structure is nothing but we can say order pair of elements. And next, Cartesian product. Cartesian product is nothing but same here. A and B be two non-empty sets. Then the set of all those elements. Set of all those elements here in Cartesian product. It should be exist order pair of elements. Already in the above definition order pair we discussed right now. So here Cartesian product means in this all the elements order pair of elements. Okay. So set of all those elements of order pair A comma B, where here A is nothing but element in A and B is nothing but element in capital B. This is nothing but called as Cartesian product of capital A and B, and it is nothing but denoted as we can write A cross B. A into B is nothing but we can call Cartesian product, we can write like this. Okay, A cross B. Suppose for example we'll take A is nothing but 1, 2, 3 elements, B is equal to 4 comma 5 comma 6 you should take. Here Cartesian product means A cross B we are taking no, right here A cross B is equal to A is nothing but here 1, 2, 3 and B is equal to 4, 5, 6 is there now. So right, pair of elements should be exist by the definition of Cartesian product, order pair of elements A comma B. So here first 1 comma 4 first you should write ma, and 1 comma 5, 1 comma 6. Okay, and next second element 2 comma 4, 2 comma 5 and 2 comma 6. Okay, and remaining 3 comma 4, 3 comma 5, 3 comma 6. It is clear ma? So order pair of elements we can write like this, and Cartesian product is nothing but we are writing A cross B and it is nothing but set of all those elements of pair of elements like this we can define. Okay, this is the Cartesian product. Next, relation. So we need to discuss definitely relation. Here relation is nothing but any two non-empty sets you should take. A and B be any two non-empty sets ma. And non-empty means what I am saying, it should be contains each set containing at least one element. Then only we can say those sets are nothing but non-empty. Okay. And any subset of A cross B is nothing but called as, any subset of A cross B, Cartesian product of A and B is nothing but called as relation from A to B. That means here any relation from A to A is nothing but called as a binary relation. Okay, any subset of A cross B is nothing but called as relation from A to B, but any relation from A to itself A2 itself is nothing but called as binary relation on the set A only, because itself set is A తీసుకుంటే itself తీసుకోవాలి. Suppose you should take B, B tends to B only. Okay, so then that function is, that relation is nothing but called as binary relation. Okay, and suppose we'll take one example. A is equal to 1 comma 2 will take. 1 comma 2 means subset, possible subsets of A. Possible subsets of A means empty set always should be exist, and singleton 1 we can write, singleton 2 and 1 comma 2. How many subsets we are getting? 1, 2, 3 and 4. So here 4 possible subsets are there. Okay, so we can find the relations like this. Okay, yeah, so now the definition relation is completed, Noma. Now the main definition is function. Okay, so we'll discuss now function definition. So in this you should take any two non-empty sets. Okay, so non-empty means what I said, it is contains at least one element. Right now B is also non-empty set. Have to write like this and here F is nothing but operation. F is the operation or relation from A to B. So here if suppose A is nothing but element in A, you should take, okay, and there exists a unique element, that is B belongs to B. So such that the pair of elements A comma B is nothing but element in F. So if it should be exist this condition, then we can say this F relation F is nothing but function or mapping also we can say from A to B. Okay, and we can say A into B also. It can be denoted as, the function is nothing but denoted as like this, F from A to B. Okay, so we'll discuss the function avali anante. Here at least A and B, any two non-empty sets we are taking, no. So by using these examples I'll explain So here A contains the elements A, B, C and B contains P and Q. Here F is nothing but mapping from A tends to B. Okay, and here this A is nothing but domain. Okay, and B is codomain. B is the codomain, as well as we can say range also. It is clear now. So here anyway this example will satisfy the function condition or not, we'll see. So A is nothing but associated to element in B in the codomain. Right now it is A tends to B means image of A is nothing but P is there. Here image of B is Q is there. Here image of C we didn't have any image right now. So it is not a function, because ఇందులో ఉండే ప్రతి ఎలిమెంట్ కి మనకు ఒక ఇమేజ్ ఎగ్జిస్ట్ అవ్వాలి. But in this one element didn't have any image. Yes, no? So that's what it is not a function. Simply you should remember in the domain every element have to exist the image. Okay, and second example, here A contains the elements A, B, C and B contains the elements P, Q, R, S. Different elements I am taking in this. Yeah, here also A have the image P and as well as Q is there. So B is the nothing but related to R, C is related to S is there. But in this case first element A have the image P and Q. Okay, so oka element ki two images exist avadu. Okay, element it should be exist only one image. Okay, so that's what it is also not a function. And what about third example? Third example, F from A tends to B is there. A, B, C elements are in A and B contains P, Q, R. But in this case each element have the images are there. Okay, okay element ki okay image exist avutundi. Okay, So this is nothing but we can say function. And what about fourth one, ma? Here fourth one is nothing but A, B, C elements in A and P, Q, R elements in B. Right now? So in this, yeah, we can say this is also function because here different elements in domain have a at least ma ఇందులో ప్రతి ఎలిమెంట్ కి మనకు ఇమేజ్ ఎగ్జిస్ట్ అవ్వాలి బట్ ఇన్ దిస్ two elements are there, two elements have the same image అలా ఉండొచ్చు రెండు ఎలిమెంట్స్ కి ఒకే ఇమేజ్ ఎగ్జిస్ట్ అవ్వచ్చు బట్ ఒక ఎలిమెంట్ కి రెండు ఇమేజెస్ ఎగ్జిస్ట్ అవ్వదు ఓకే సో two elements ki one unique image exists అయితే this is also we can say function. And fifth one is there. Here F from A tends to B is there. A, B, C. Here P, Q, R, S. So A is related to P, B is related to Q, and C is related to R is there. But in this case, S is it doesn't contain any relation, whatever it may be. But domain lo unde prati element ki manaku image exist ayinda leda adi check chesukovali. So domain lo unna prati element ki manaku images exist ayyayi kada. In the codomain, no need to consider. By the definition of function, no need to consider. Okay, so we can say this one is also function. So by using these examples, okay, we need to discuss about domain, codomain and range. So from each example we can write the domain and codomain range ma. Domain is nothing but domain lo unde elements. A is nothing but domain we are saying, no? So domain lo what are the elements ma here? A, B, C. Right now domain lo unde elements annitlo chudandi we have A, B, C only. So here you should write A, B, C are the elements in domain. And codomain means I am saying B. B means from the last one I am writing here. B is nothing but contain the elements codomain P, Q, R, S. Right now P, Q, R, S. That is nothing but codomain. And range. Range is nothing but only we have to write images. Okay, only write we have to images. So those are images ma. A have the image P and B have the image Q and C have the image R. So P, Q, R are the range. Okay ma? Yes ma. Now we'll discuss types of functions. Okay, yeah, types of functions. The first definition is one-to-one function. We'll discuss ma. One-to-one function ni injection also we can say. Okay, both are same. So we'll discuss this one, no? Yeah, the operation F from A tends to B is there. Here this F is nothing but function, right now. So this function is nothing but we are saying one-to-one. One-to-one condition satisfy avalante. So if distinct elements of A is nothing but domain, right now distinct elements of A have the distinct F images, distinct F images in B. That is the definition of one-to-one function or injection. Okay, so manaku best example, suppose that means what ma F is a mapping from A tends to B is a one-to-one function means suppose any two elements in domain you should take A1, A2 I am taking in A and A1, A2 both are distinct. Both are distinct elements. Then F of A1 not equal to F of A2 only. Suppose if A1, A2 both are elements in A, A1 equal to A2, both same elements exist, then we should get F of A1 equal to F of A2. Either this condition or this condition. Any one of the condition is correct. Okay. So here by example we'll discuss ma. Here first example is nothing but A have 1, 2, 3 and B have 4, 5, 6 are there. So what I am saying by the definition of one-to-one, if distinct elements of A have distinct F images in B. So one have the image 4, 2 images 5, 3 images 6. Distinct elements are there, distinct F images are there. So we can say this is nothing but one-to-one function. This is one-to-one function. And what about this one, ma? This one is nothing but here distinct elements 1, 2, 3 in A is there, 4, 5 elements are in B is there, but here 1 and 2 have the same image. 1 and 2 have the same image. Here 3 have the image is 5, but in 2 elements ki image is nothing but okate undi. Kabatti what is the definition, ma? Distinct elements have the distinct F images have to exist in one-to-one. So that's what it is not a one-to-one function. Okay. And third example is 1, 2, 3 are elements in A, B, C, D are elements in B. Okay. So here one image is A, 2 images B and 3 images C. Prati element ki domain lo unna prati element ki different F images are there, no? Remaining element no need to consider in the codomain element. Okay, so that's what we can say. This one is also one-to-one function. Okay, and one more. Suppose let f of x equal to some equation, linear equation I am taking. Okay, 3x plus 1. By using this condition, this one-to-one condition will prove this function should be satisfies one-to-one condition or not. Okay. F of x is equal to 3x plus 1. So now I am taking distinct elements we have to take, no? So that's what f of x1 is equal to 3x1 plus 1. x1 is different. And f of x2 is equal to 3x2 plus 1 I am taking. Different two functions I am choosing. And if suppose these two functions are equal to each other I am taking, because by the definition of one-to-one function, f from A tends to B is one-to-one function, then what is the condition? Either first one or second one I am saying no. So I am taking second condition. If suppose f of A1 equal to f of A2, then we need to prove A1 equal to A2. Okay? Yeah, we'll see. F of x1 is equal to f of x2 I am taking. What is f of x1? 3x1 plus 1 is there. Right now? And instead of this, write this. It should be equal to f of x2 is equal to 3x2 plus 1, right, on the right hand side. Okay, and on both sides here plus 1, on the left side plus 1 is there. Both ones are cancelled, ma. Remaining terms are 3x1 is equal to 3x2 are there, and again 3 also gets cancelled on both sides. Remaining x1 is equal to x2. That means what, ma? By this condition satisfies the one-to-one condition, na? F of A1 equal to f of A2 means A1 equal to A2 is there. So f of x1 is equal to f of x2 means x1 is equal to x2 we got. So therefore what we can say here, this function is nothing but one-to-one function. It is clear? Note this point. Yes. Now the next definition, ma, in types of functions, onto function. Onto function is nothing but called as a surjection also. Yeah. The function is nothing but operation f from A tends to B. This function f is nothing but said to be onto function. Onto function avvalante ma, if the range of f is nothing but is equal to codomain of f. Range of f is nothing but equal to codomain of f. That means what, ma? F of A is nothing but equal to B have to exist. Okay. Yeah. Here with example we'll discuss. F is a mapping from A tends to B. Here A is nothing but contains 1, 2, 3 and B contains A, B, C, D. I am taking here image of 1 is A, image of 2 is B, image of 3 is C is there. Is it satisfies one-to-one condition or not? Because every element have distinct images are there. Yes, no? About D, you should we can leave it now. But here every element in domain, it has each and every element have the relation in codomain. So we can say it is one-to-one. As well as here the condition of onto is nothing but what is there? Range of f is nothing but equal to codomain of f, no? Range of f. Codomain is nothing but how many elements are there, ma? A, B, C, D. Right now? And the range is nothing but its images. Its images. What are the images? A, B, C. Here only 3 elements are there. here A, B, C, D are there, not equal. So what we can say here, it is not a onto function. Okay, whatever. Now the second example ma, here f is a mapping from A tends to B, and A contains 1 2 3 and B contains 4 5. Here every element have the images, but here codomain is nothing but 4 5, because we are discussing about onto function. So the condition is nothing but codomain is nothing but range only. That means range of f is nothing but equal to codomain of f na. So codomain 4 5 and range also it have the images. So 4 5 both are equal. So codomain is equal to range. We can say this is onto function. Okay. Now here one more definition, bijection. Bijective function we'll discuss. So bijective function means function is nothing but mapping from A tends to B. Okay. So this function f is nothing but satisfies both conditions. That is, one is one-to-one function as well as onto function. If it should be satisfies these two conditions, then we can say this function is nothing but said to be bijective or bijection from A tends to B or A to B. Okay, this is the definition of bijection. With example we'll discuss. Here I am taking f from A tends to B is there ma. F A contains 1 2 3 and B contains 4 5 6 7. Okay, so here one image is 4 is there, 2 images 5 is there, 3 images 6 is there, 7 you should leave one. So here every element have the distinct images are there. So we can say it is one-to-one function. Yes, no? Clearly we can say it is one-to-one. And what about onto? Onto is nothing but codomain. Codomain 4, 5, 6, 7. But range is nothing but images. How many are there? 4, 5, 6. Right now? So both are not equal. So here onto condition is not satisfying. So here one-to-one satisfying, onto not satisfying. That means here actually bijection means we are checking bijection condition. Bijection means it should be satisfies both one-to-one and onto. ఆ రెండిట్లో ఏ ఒక్కటి సాటిస్ఫై అవ్వకపోయినా it is not a bijection, right? No, so therefore here we can say this function f is not a bijective function. Okay, not bijection. And we'll discuss second example also here. And here f is a mapping from A tends to B, and A contains 1 2 3, B contains A B C. Every element have the images, means each distinct elements and distinct images are there, satisfies one-to-one condition. Okay, and what about onto condition ma? Codomain is nothing but ABC and image also ABC. Range is also nothing but ABC, because every elements images here ABC are there. So therefore codomain and range both are equal. So we can say f of A equal to f of B. B condition existed. Here satisfies one-to-one and onto condition existed. That means what we can say, the function f is nothing but bijective function from A tends to B. Bijective function from A tends to B. So these are the main definitions of functions ma, one-to-one, onto function and bijective, and more definitions are there. Many one-to functions are there, one-to-many functions are there, identity functions are there, constant functions are there. So we'll discuss one by one definition. Okay, yeah, note these definitions ma. Yeah, this example ma, A contains 1 2 3, B contains A B C, right now. So here image of 1 is A is there, image of 2 is B is there, image of 3 is C is there. Satisfies one-to-one because distinct elements in A have the distinct F images. Anyway, and one onto condition, image of 1 is A, image of 2 is, means F of A is nothing but equal to B. This condition have to exist. That means codomain is nothing but equal to range. So here codomain nothing but 3 elements are there, and image of in this also 1 2 3 are there, 3 elements, both are equal. So satisfies onto condition also, f of A equal to B also. And one more, what is there ma? Yeah, satisfies one-to-one condition and onto condition. Then what we can say, given function f is bijective function. Okay. So these are the main definitions in functions, types of functions, and more definitions are also there. Constant function, identity function, many one-to function, one-to-many functions. So many definitions are there. So one by one we'll discuss. Okay.